makes sense. Because 4 minutes to 78 seconds, I was like, that doesn't really make sense. But
Well,
let's see.
well, you're
Oh,
right. That wouldn't make sense because for one thing, that's 5 minutes and 18 seconds.
right.
Okay, so you got to be a little careful. When they said 7 minutes and 45 seconds, you wrote it
Uh-huh.
correctly as 7.75 minutes.
Right.
But you have to understand that a full minute is only 60 seconds. So
Right.
this seconds is never going to be greater than 60.
No. And then, yeah, I got 4 minutes and 59 seconds for that.
Well,
After
even
I,
that doesn't make sense. In other words, that's bigger than what you started at.
uh,
So here, do you have your calculator in front of you?
I do, yeah.
So take 0.99 to the 52nd power,
Okay.
multiply that by 7.75. What do you get?
4 minutes and 59 seconds.
Hold it. What do you get exactly?
4.59549.
That's minutes. That is not the same as 4 minutes 59 seconds.
Oh, that's not the same.
No.
Okay.
In other words, there are 60 seconds in a minute. So
Right.
if you want to give your answer in minutes and seconds, then you got to convert that 0.59 minutes to seconds.
Okay.
Multiply that fraction, just the 0.59 and however many decimal places you want,
Uh-huh.
times 60. What do you get?
35.7294.
Now we have an answer that makes sense.
Okay.
In other words, now your time is reducing. It
Right.
definitely is decaying, as it should be. Your time should be getting lower and lower and lower. And
Yeah.
that translates to 4 minutes, 36 seconds.
Okay.
How much you round it off to, that there don't appear to be any directions to tell you, so
No. So,
whatever your teacher usually wants.
mm-hmm.
All right, let's see.
Cool.
So B, by which holiday will you be able to run a mile in under 6 minutes? So we've got the right equation.
Yeah.
Hold on a second.
No worries.
Everything else I have on my desk here.
Okay.
Now, y is your time, right?
Yeah.
And that's times 0.99 to the t. So
Oh,
they want to know when y will be less than 6. Or
yeah.
let's just make it 6.
So that'd be 6 is equal to, right?
Now notice, hold on. Notice that I have one equation and only one variable in that bottom
Right.
line. That means I'm
Yeah.
going to be able to solve for it. But in order to solve for t, I've got to use logarithms. There's
Okay.
not going to be any common exponential base with these kind of numbers.
Okay.
Okay, that common exponential base is, you don't find that in the real world. And the
No.
reality is that when you have exponential equations, you have to use logs to solve it.
Okay.
Okay, I mean, they
Yeah.
start you off in exponential 101 by giving you those 5 or 6 problems that we did yesterday, where you can
Hmm.
solve them by finding a common exponential base, and you don't have to use logs.
Right.
But in real world problems, you do. So what's the
Okay.
step here?
So,
All for t.
would we divide 7.75?
Well, you're close. Divide 6 by
Or
7.75. Yeah, I want to get rid of that 7.75.
okay.
Okay, so I got to divide both sides by that.
Okay.
That give you on the left?
Okay, so you get 1.29.
No, get it backwards.
Did I do it backwards?
Always know when you're taking a smaller number and dividing it by a bigger number, you are not going to get an answer greater than 1.
Oh, yeah, I did 7.75 divided by 6. My
Right.
bad.
I knew
So,
that.
yeah.
Okay,
Yeah.
so what's 6 divided by 7.75?
0.77.
What is it?
0.774194.
All right. There's always a question as to how many
Yeah.
decimal points you want to place on that. Okay,
Uh-huh.
now this becomes this.
Yep.
Now what's the next step?
Um, let's see. Then the next step we have to get rid of t.
Now hold on, we're trying to solve for t. We got to get t down on the algebra line. Right now it's not there. Right now it's in the exponent. How do you
Okay.
get it down to the line, the algebra line?
Um,
You take the natural log of both sides. Remember that you
that's right.
always use logs to solve these problems.
Right.
So at
Yeah.
some point, you're going to have to take the log of both sides and just use natural log.
Okay.
Okay? Remember,
Okay.
like any equation, you can do whatever you want to one side as long as you do it to the other. Well, that includes taking the natural log.
Okay.
Now, what's the next step?
And then we would, hold on. Okay. So now we would, let's see.
The key reason we took the natural log of both sides.
To get t down to the algebra line.
Well, how do we get it down to the algebra line?
Um, would we,
The log of x to the y equal to. This is one of the more important log rules.
um,
Y times log of x.
right.
In other words, the rules of exponents, the rules of logs allow you to take that exponent and move it down to the algebra line.
Okay.
Okay, so I can move that t down in front. So now I have the natural log of that equals t times the natural log of that. Now how do I
Uh-huh.
solve for t?
And then now we would, let me see. Um, divide by 0.99? No.
Divide by natural log of 0.99.
Yeah. Yeah.
In other words, yes, that is just a number. And the fact that it's to the right of t instead of to the left of t is the difference between me saying 2x, that's the same as x times 2.
Right.
So the fact that it's to the right, it's still a coefficient. And for me to get rid of it, I got to divide both sides by that.
Okay.
All right, so now I got natural log of 0.77 divided by natural log of 0.99.
Okay.
That's going to be a negative number, and that's going to be a negative number, which means your answer is going to be positive, which is what we want. And it's going to
Exactly.
tell you when your time is going to be 6 seconds, where now it's 7 minutes 36 seconds. It's going to tell me how many weeks it's going to take.
Right.
So what do you get when you solve for t?
I get minus,
No,
nah, that's not,
you got your parentheses wrong or something.
so I did natural log of,
Remember when you take the natural log, any kind of log of a number that's less than 1, you get a negative answer.
right.
So both your numerator and your denominator got to be negative. So there's no way you're getting a negative
Gotcha.
answer.
Okay. Yeah, gotcha.
So when you come up with a negative answer, it generally means you got your parentheses in there wrong. In other words,
Okay.
it's not reading what you put in there the way you want it to. So
Yeah.
it's always good to know a ballpark answer.
Yeah. I got another negative. Hold on.
All right. Do the natural log of 0.77. Give me the answer.
Okay, hold on. Oh, 0.77. Negative 0.26. That doesn't sound right.
And that's correct. And now,
Is that right?
yeah, and then now do the natural log of 0.99. What do you get?
Natural of 0.99. You get negative 0.01.
Now divide those two things, and that's how many weeks it's going to take.
Okay.
Now, when you said 0.01, how many zeros were in front of it?
Just one.
You sure it was 0.01 and not 0.001?
Yeah, 0.01. So I get
Yeah,
26.0065.
that's 26 weeks.
Mm-hmm.
Well, that doesn't make any sense. In other words, we went from 7.75 down to 7.59 in 52 weeks.
Yeah.
So clearly to get all the way down to 6 minutes, it's going to take longer than 52 weeks, right? If you're lopping off 1% per week from your
Yeah.
time. So that can't be the right answer. And that's what leads me to believe that you might have one of these answers off by a power of 10. Let me get my calculator.
Okay.
In other words, 260 weeks would make a lot more sense.
Right.
I don't know that that's the answer, but let me figure it out here.
Not sure either. Yeah.
So I got control natural log of 0.77.
Uh-huh.
Then let me hit enter on that. Okay, that's negative 0.26.
Yeah.
And I have natural log of 0.99. Were there any additional numbers onto that? Yeah,
Um,
I get
was there?
0.01005, and 1 divided by the other gives you 26.
Oh, okay.
Yeah, what's going on here? I must have made a mistake in the math.
Yeah.
Let's see, we got y equals the start, 7.75 minutes,
Mm-hmm.
times the rate, times t. Well, now it makes me question our other result.
Yeah, me too.
Uh, let's see. When t was 52, let me see what 0.99 is. Just a second.
Okay.
0.99 raised to the 52 power gives you 0.5929, but then we have to multiply that by 7.7, excuse me, by 7.75.
Uh-huh.
Hold on.
Okay.
Now, see, I get 4.59 when I did it.
You got 4 point what?
5.
5.9?
In other
Oh, okay.
words, at the end of a year,
Yeah.
your time is going to be down to almost 5 minutes, 4.59 minutes.
Okay.
That's like 4 minutes, 36 seconds.
Yeah, which is what I got.
Well, and now that makes sense that
Mm-hmm.
how long does it take to get your time down to 6 minutes? Well, that's going to be less. It's not going to take 52 weeks, right?
Right.
And the answer we came up with was approximately 26 weeks, which now makes perfect sense.
Uh-huh. Okay.
So,
So we did do it right.
yeah, we made a mistake on part A, and
Uh-huh.
that caused us to have a totally incorrect ballpark figure.
Okay.
Okay, so here's part A. Make sure you see this. Um,
Uh-huh.
Part A is actually very easy. See
Yeah.
the top line? Plug,
Uh-huh.
plug in 52 for T, and whatever you come up with is the answer. And what I came up with was 4.59 minutes.
Yeah.
Translates to
That's what I
4 minutes, 36 seconds.
got. Uh-huh.
So if it takes a year to get down to 4 minutes, 36 seconds,
Mm-hmm.
then taking 26 weeks to get down to 6 minutes makes perfect sense. Okay.
Okay.
That might have been all my fault. I see right now you had 4 minutes there. For some reason I was thinking it was 6 minutes.
No, no worries.
So
Yeah, this stuff's
let's
it's
see, by which
definitely
holiday will
challenging.
you be able to run it? Valentine's Day, 4th of July, or Thanksgiving? Well,
Huh?
26 weeks.
Yeah.
Which holiday will you be able to do it?
So 26 weeks would be, that would be the 4th of July, right?
Well,
No.
June 30th would be half a year,
Right.
26 weeks. So
Right.
yeah, by June 30th, you would have been doing it 26 weeks. So by the 4th of July, you'd be running under 6 minutes.
Cool.
Yeah, okay.
Alright.
Yeah, the Richter scale has always been kind of fascinating to me.
Oh, I think it's cool.
Yeah,
Yeah.
well, it's because an 8.2 is 10 times more powerful than a 7.2.
Really?
Uh-huh. It's not
Oh,
just a little bit more powerful.
no,
It's
that's
it's
a
a logarithmic.
big difference.
And
Yeah.
if you were to use the logs, you'd realize or see that there's a gigantic difference between 7.6 in this problem and 9.2.
Wow.
Uh,
Yeah. It's a pretty big difference.
well, one is going to be like 20, almost 20 times more than the other.
Hmm.
Let me read the whole problem.
Okay. Yeah, earthquakes are, they're, don't want to mess around with them. They're pretty scary.
Especially the really big ones.
Oh, yeah.
Strongest earthquake on record was 9.5.
I think, wasn't that Anchorage or was that Chile?
That was in Chile in 1960. The one in Anchorage or the one in Alaska was 9.2. That was
Okay.
1964. I actually remember that.
Yeah.
I was 15 years old. I remember how huge that earthquake was.
Wow. I was watching National Geographic, and they said that San Francisco or the California coastline is due for a
Yeah,
magnitude 10 or above
I know.
earthquake, which it would be around like a 4-point magnitude earthquake here. Like that's how powerful it would be,
Yes.
which is
Well,
it's just
we
that's
don't have
terrifying.
we don't have big earthquakes here. We have a lot of little tiny earthquakes, but Denver
Yeah,
has.
like microquakes,
We
I think is what.
actually live in a great place for everything. We don't have very many tornadoes. We don't have earthquakes. We don't have floods that much.
Right, which is
Um,
nice. Yeah.
yeah, we get snowstorms
Don't have,
every now and then. All right,
yeah.
so let's figure this out.
Okay.
R is how severe it is.
Mhm.
So, now hold it. No, it isn't. Just a second. Oh, shoot. Um,
No worries.
I have an 8 o'clock.
Oh, okay.
That's why I was able to move you up to 7:30 was because I had an
I
8
appreciate
o'clock.
that.
So I'm going to have to leave. I'm not sure I'm going to have time to get this done, but maybe. We still got a few minutes.
Yeah, no worries. I appreciate you fitting me in.
So R if, let's see, the Richter is base 10 of log of how severe the equations were during the earthquake. So it was a 7.6 was equal to the log base 10 of the severity, which we'll call x.
Okay.
Okay? And the question is, how much bigger was Alaska over India? Well, the Alaskan one was 9.2 equals the log base 10 of x. And remember what x is. X is the severity.
Mm-hmm.
So this is a different x. We better call that y.
Okay.
Okay. So let's see. If I solve this, it's comparing 10 to the 7.6. That's what x is equal to. And
Okay.
y is equal to 10 to the 9.2. So the difference between those, I'm going to subtract my exponents, and I'm going to get 10 to the 1.6, which is 16 times. In other words, 10 to the 1.6 is 16.
Right.
So the Alaskan earthquake is 16 times more than the Indian earthquake. And you pretty
Cool.
much want to show your work exactly like I've done it.
Yeah.
The first line is R, the Richter scale reading equals the log base 10 of x, where x is the severity.
Okay.
And then you have this one for India. You have this one for Alaska. And it's all I have to do is solve for x and y,
Cool.
and then compare the two by dividing the bigger one by the smaller one.
Okay. And then for 10 to the 1.6, where we just move the decimal over, is that how you did that?
Yeah, 10 squared is 100.
Right.
10 to the 1 is 10. So 10 to the
Mm-hmm.
1.6 is 16.
Uh-huh.
I think. I mean, do it in your calculator, but
Yeah, that's right. That sounds
is that
right.
what it says? 16?
Yep, it's the 16.
Okay.
Uh, yeah.
All right. Dylan, I got to
S-
run.
Sounds good.
Hopefully that helps you proceed through the rest of these problems also.
That did help, yeah.
I don't know.
No, I appreciate you fitting me in. I know it was kind of,
Yeah, these
yeah,
are tough problems. There's nothing
yeah.
easy about these.
No, definitely not.
All right. Dylan, I'll
Uh,
talk to you. I presume we're not going to have a session tomorrow night?
let's keep that. I have a quiz on Thursday,
Oh, okay.
so I'll get review tomorrow. So if we could keep that at 8, is that
Yeah,
correct?
let me put it back in because I think yeah.
Okay.
Okay. I'll put you down for 8 tomorrow night.
Sounds good.
All right.
Awesome.
Dylan, talk.
Thanks, Mr. Callen.
Bye-bye.
Sounds good. Bye-bye.